So we're looking at the responses from conjugate magnetometer chains in Antarctica and West Greenland. Specifically, we're interested in when these responses are different, because typically we would expect them to be very similar because they're conjugate locations, meaning that these magnetometers are at the foot points of the same magnetic field line. And so what we're interested in investigating is when these responses are different and what drives these differences. So what we've done is we've looked at the overhead field line currents from Ampere, and we looked at the difference between the north and south overhead field line currents at the same time as the magnetometer differences. And so we tried to identify when these peak differences in the overhead field line currents correspond to peak differences in the magnetometer data. And what we found was that about 70% of the identified peak differences in the magnetic field data correspond to peak differences in the overhead field line currents, which means that these overhead field line currents are a major driver of these asymmetries that we see in the magnetometer data, which is expected. So going further, we're going to be looking at conductance as maybe a factor that makes up for the extra 30%, things like solar insolation. And talking to other people here at AGU, being able to discuss ideas about that extra 30% that might make up those asymmetries in the magnetometer data is a great opportunity here. I've been able to talk to a lot of people about it.